we present Magic3D, high-resolution text-to-3D content creation from NVIDIA. Industries including autonomous vehicles, robotic factories, game designing, and movie production all involve creating virtual digital worlds. 3D content creation plays a crucial role in these applications. However, 3D content creation is typically a laborious process and requires professional software and skills to reach perfection. Magic3D can generate high-quality 3D mesh models from text input. Our goal is to turbocharge 3D content creation to reduce the time and effort that is required. Here are some results of our 3D generation. Magic3D can understand the input text and create 3D mesh models according to the text descriptions, like a bunny sitting on top of pancakes. The 3D meshes also include detailed geometry, like the skin of the iguana. We have seen some great success in 3D generative models, and the quality has significantly improved in recent years. These models can work well in category-specific domains like cars or chairs, but in general, 3D datasets are still hard to obtain at a large scale. So the questions are, how can we scale up the available training data, and how can we improve the diversity in datasets to enable zero-shot capabilities? Recently, DreamVision introduced a solution to this by capitalizing pre-trained text-to-image generative models, which allows one to generate 3D shapes from text with great zero-shot capabilities. It can create 3D shapes describing diverse concepts, such as a squirrel playing the saxophone, among many others. However, DreamVision suffers from several limitations. It can take 90 minutes to optimize a single 3D model with lack of details in the low-resolution rendered images. Our solution, Magic3D, addresses these issues. In addition to enjoying the same benefits as DreamVision, Magic3D generates 3D mesh models at a high resolution with much more details at a faster speed. Here is an example of a blue poison dart frog sitting on a water lily. Magic3D is a two-stage pipeline to optimize 3D models in a course-defined fashion. In the first stage, we use a text-to-image division model in the image space, conditioned on the input text prompt. We optimize the instant NGP neural field by rendering at multiple viewpoints. At each step, we randomly sample a camera location and render the image at a low resolution. We add a random amount of noise to the rendered image, feed it into the edified division model, and denoise it by subtracting the output by the same noise. This noise residual is used to compute the loss. We use the score distillation sampling loss proposed in DreamVision that simplifies the gradient formulation, allowing optimization to be still effective but much more efficient. The SDS gradients are used to update the instant NGP. Unlike DreamVision, our same model allows efficient acceleration data structure designs with lower memory consumption. After the instant NGP becomes optimized, we extract an initial 3D mesh using the MTET, which serves as the initialization for the second stage optimization. We use Stable Diffusion as the high-resolution division model here, conditioned on the same text prompt. As in the first stage, we sample a camera and render the image, this time at a higher resolution. We encode the image into the latent space and follow a similar procedure to add noise, denoise it with the U-net, and finally computing the SDS loss. The gradients are backpropagated to update the texture and geometry of the 3D mesh. Mesh optimization can be very fast using differentiable graphics rendering engines, allowing us to render and optimize at a much higher resolution. As a result, Magic3D can generate detailed texture and geometry on the 3D mesh. We make a comparison against DreamVision. Using the same input text prompt, Magic3D generates more detailed 3D shapes of much higher quality. Here are some more examples of an astronaut statue, as well as a ceramic lion. Magic3D enables users to control the generated 3D meshes in various ways as well. As an example, we can take an optimized 3D model and continue the optimization with the new input text prompt, and the 3D model would quickly transform into the new 3D mesh of different shapes and styles. The 3D meshes generated by Magic3D are ready for various graphics rendering engines for creative applications. We showed an example where the meshes are exported to NVIDIA Omniverse. Magic3D will help both expert and novice 3D artists to boost their creativity in 3D content creation in various new ways. Please visit our project website or contact us at CVPR to learn more. Thank you.